Dear students, greetings of the day. Today we are going to discuss the different addressing modes. First, we should know what is addressing modes, why it is needed. That is the way any operand is selected during the program execution is depend on the addressing mode of the instruction. The main two purposes of using addressing modes are to give the different style of programming to the user and to reduce the number of bits in the addressing field of the instruction. These are the two main things we are going to discuss about the different types of addressing modes. Before discussing the different types, we should know what do you mean by effective address. Effective address is nothing but address of the operand. That is where the operand is stored. That address is called, we call it as effective address. You will see the different addressing modes one by one. The first one is called immediate mode. In this mode, the operand is specified in the instruction itself. For example, add 7. Here the 7 is the operand that is specified in the instruction itself and is available in the accumulator register. This type of addressing mode is called immediate mode. The next one is called register mode. In this register mode, the instruction contains the address part of the operand. That is, the instruction itself, it contains the effective address. But the operand is stored in a CPU register. That is called register mode. And next one is called register indirect mode. In this, the instruction contains where the effective address is stored in the CPU register. Then the CPU register points the operand available in the memory. You can see where the address part of the instruction contains the where the effective address is stored in the register. It in turn denotes the where the operand is stored in the memory. This type of addressing mode is nothing but register indirect mode. The next one is called auto increment or decrement mode. First we will discuss auto increment mode. It is also as like this above. That is, the instruction part contains the effective address of the operand. That is 3300 is the effective address where operand is stored. Here the operand is 6B. After returning the operand from 3300, that is 6B, it will be incremented and denote the next value 7F. So it is called as auto increment. Here incremented, the word size, here word size is 2 bytes. So it will be incremented by 2 bytes. This is called as auto increment addressing mode. The next one is called you have to note here. First the operand value is fetched. Then the insertion register auto value is incremented by 2 bytes. As I said earlier, here 6B is the operand. After retrieving the operand only, it is incremented by 2. That you have to remember. Then next one is called auto decrement mode. In this mode, the effective address equal to content of the register minus step size. Here the step size is 2 bytes. So see the diagram. As usual, the address part of the instruction contains the effective address where the operand is stored, but in this case it will be decremented 2 bytes. That is, instead of 6C, it will access only the 1F because this is auto decrement addressing mode. That is, the first instruction register R auto value is decremented by the 2 bytes, that is step size. Then the operand value is fetched. So here the operand is 1F, that is fetched after decrementing from the effective address. Direct addressing mode. Here the address part of the instruction contains the effective address where the operand is stored in the memory. For example, add R1, 4000 means here the 4000 is the effective address where the operand is stored. Then next one is called indirect addressing mode. Here the address part contains where the effective address is stored in the memory. That in turn represents where the operand is stored. There are two references in this indirect addressing mode. First reference is to the memory where the effective address is stored. The second reference is to the data from the effective address where the data is stored. There are two references to the memory. Then the next one is called index addressing mode. Here, the contents of the index register is added to the address part of the instruction to obtain the effective address. So, index register, so the register part denotes the where the effective address is stored in the register. We have to add the index register value with the effective address to obtain the effective address of the operand from the memory. First, we have to add the register value with the address part of the instruction to obtain the effective address from the memory where the operand is stored. Then next one is called relative addressing mode. Here, contents of the program counter is added to the address part of the instruction to obtain the effective address. So here we have the reference from the base register to the register set. We have to add the content of the PC to obtain the effective address from the memory. That's all about the addressing modes. Thank you.